Dear students, in continuation to the binomial distribution video 1, in this video we are going to practice in another problem based on binomial distribution, probability distribution. Here the given problem is, if x is a random variable following binomial distribution with mean value 2.4 and variance 1.44, find p of x greater than or equal to 5. Okay, so they said it's a binomial distribution, mean value is 2.4 and variance is 1.4, and they asked you calculate p of x greater than or equal to 5. First let us note down the given values in the problem. Mean is np, okay, that is equal to 2.4. Variance is npq, that is equal to 1.4. So np value is 2.4, you can substitute here. So n into p into q. So n into p is 2.4. So 2.4 into q is equal to 1.4. So q is equal to 1.44 divided by 2.4. So q is equal to 0.6. Based on this we can calculate the p value. P is equal to 1 minus q. So 1 minus 0.6 is equal to 0.4. So p value is 0.4. Now we can calculate n value, because n into p is equal to 2.4. So n into p is 0.4, that is equal to 2.4. So n is equal to 2.4 divided by 0.4 is equal to 6. So n value is 6. Now we can calculate, we have to calculate p of x greater than or equal to 5 based on the binomial distribution. So this is the binomial distribution equation. Okay, now we have to calculate p of x greater than or equal to 5. First we have to understand, with the previous problem we have calculated first two terms, that is p of x is equal to 0. 0 is the first value and 1 is the second value. But here they are asking to calculate p of x greater than or equal to 5. Greater than or equal to means it is more than 5 and also 5, because it's equal to 5. Equal to 5 means 5 also included and above 5. So 5 and above all the values. So we do not know what is the end, the final value is not given. Okay, 5 and above, that is mean x greater than or equal to 5 means 5 and above. So you can go to 1000, lakhs, crores, goes infinite. Okay, we cannot calculate for each number 5, 6, 7, 8 like that up to infinite we cannot calculate. Okay, separately. So what we can do is, total probability is 1, that we know is. So total probability is 1. Okay, so if you deduct 1 minus p of x less than 5, because greater, here capital X is greater than or equal to 5, we need to calculate the binomial distribution for x greater than or equal to 5. Okay, 5 and above. So remaining what is left, 0 to 4. Okay, so total probability is 1 minus, if we calculate p of x less than or 5, if you deduct that value from the 1, you will get a remaining value. Remaining value is what? P of x greater than or equal to 5. Okay, so this is the method you can calculate, because up to less than 5 means 0, 1, 2, 3, 4. So only 5 values we can calculate that. But greater than or equal to 5 means 5 and above infinite. Okay, we cannot calculate all those values. So this is how we have to calculate. Okay, so 1 minus p of x less than 5. So 1 minus p of x less than 5 means what? X is equal to 0 plus p of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4, because less than 5. 5 is not included. Less than 5 is up to 4. Okay, first value is 0, second value is 1, third value is 2, and fourth value is 3 and fifth value is 4. So now we have to apply this equation for each value. P of x is equal to 0. Okay, 6 is 0. 6 is n value, n is 6, 6 is 0. P is 0.4 to the power 0 and Q is 0.6 to the power 6. 6 is n minus x, n is 6 minus x is 0, so 0.6 to the power 6. Similarly 6e1 0.4 to the power 1, 0.6 to the power n minus x, n is 6, 6 minus 1 5, so like that 6e2, 6e3, 6e4. okay, now if you see, you have to simplify all this. Okay, so this is the thing. Okay, you have to simplify this. If you simplify this, okay, you will get the final value. Okay, so 1 minus, if you simplify all these 5 values, P of x is equal to 0, x equal to 1, x equal to 2, x equal to 3 and x is equal to 4, you will get 0.959. okay, see the 5 values and add all these values, you will get 0.959. so 1 minus 0.959 is 0.041. so this is P of x greater than or equal to 5. okay, so this is how we have to calculate. Okay, fine. The next video we will discuss one more problem.